industry. The agenda. I will do a slight introduction to let you understand the whole area I'm interested in and the area I work in. Then we'll speak about BSD routing facilities, and we'll make a comparison with commercial solutions. Then we'll speak about MINAP and the IX experiences around Europe. So who am I? I'm Intel's CTO. I'm responsible for network operations, and this is me at work managing our network. I actually was on top of this. We are full-featured ISP and wireless ISP, where wireless DSL is our main product. ADSL, SHDSL, and colocation are other areas of business. We are AS43843. We also have a sister company, which is called ASD. You'll notice that it's easy to type it into your computer. That's why we don't get any answer back from our sales requests because they think it's spam. But yeah, ASD is a full-featured ISP as well, but it's focused on residential WDSL access, and Pop Wi-Fi is its main brand. It's AS28929. So we have coverage throughout northern and central Italy via WDSL, and it's national via ADSL and SHDSL, which means we cover all the town and surface covered by cable access. We do peer in many locations. We peer at MINAP MIX, which is the Milan Internet Exchange. We peer at Swiss IX in Zurich. We peer at TIX, which is the Tuscany Internet Exchange. We peer at Hispanix, which is in Madrid, and Torix, Swedish. We are finishing setting it up. Torix is Toronto, the Toronto Internet Exchange. We have built our networks from scratch. The two companies came out at the same time in different parts of northern Italy, and then we managed to get it all summed up together. We had no investors, no huge budgets, and the goal was to provide broadband in rural areas. Since you're mostly from Japan, you probably don't understand this, but Italy has an ADSL coverage of 33% of the whole country. So if you live outside of a city, you will probably not get broadband access. The only way was to develop a network which was totally outside of the normal network, of the landline network, to provide ADSL access to people outside cities, which represent more than 66% of the whole population. And we have to keep costs low because people not living in the city probably have lower wages. So we initially looked at BSD routing facilities. There are a bunch of them. Some are BSD natives, some are written for Linux, and they are OpenBGPD, Quagga, OpenOSBFD, and Bird. I didn't include Zebra because I didn't think it was really interesting. So OpenBGPD was developed as part of OpenBSD. It's the most flexible you can see out there. It was used by many IXes, and we'll see that later on. It supports atomic operations, which means you can modify your config file and then have OpenBGPD load it, and then modify the routing table relating to your modifications. And it's available on FreeBSD and NetBSD as well, with restrictions applied. There are some routing facilities which are not available on FreeBSD and the FreeBSD network stack, which are in the OpenBSD network stack and which cannot be used, like multiple routing tables and such. Quagga derivates from the Zebra project. It's the older piece of software in this list, and the architecture reflects its age. It has a Cisco resembling interface, which means you connect to its port, and you can have it run on different ports. You connect to its port, and then make the modifications as you were on a Cisco router. What does it mean? It means that you insert one line per time, and it applies your configuration to the running configuration file. Sometimes this leads to routing leaks. You configure one of your neighbors in one of your connections, and it leaks your full routing table because you still don't have applied filters. And this creates problems when you're running with your peers and want to remain friendly with your peers. And then there's BERT, which is the last but not least. It was financed by the Czechnik, and it's new but a mature and scalable product. It's surpassing Quagga in usage in heavy loaded environments, and we will see that later on. OpenOS PFD. It's similar to OpenBGPD, just different protocol, and it's used as an IGP. And supports atomic operations as well. So summing up, they all support IPv4, they all support IPv6, they all support AES32, and they're all open source. But anyway, common wisdom is that pfSense is the only routing product out there. Not many people know about OpenBGPD and OpenOS PFD and Quagga, and I do love pfSense. I contributed to the FreeSpeed project from which it derives. So, yes. And actually, pfSense can be used for just more than Soho. But there's a general belief that this is only a solution for small environments. We're using it now at Taurus, though it's working well. We're still in a beta phase, but we're using it and it works. And bigger environments tend to not use, due to it not being backed up by a well-known company. If you go to a big carrier and tell them to use something less expensive than what they're using right now, they'll tell you that it wouldn't work, and even if it's not true. So they prefer to throw cash into support. They prefer to throw cash into having someone from a company tell them that they're doing things the wrong way, or probably that they need to put more money into it, and that's it. And so we have customers asking us advice on hardware software solutions to implement. We often try to convince them to go the BSD way, but it's hard. And what are those selling points? First of all, budget. They get the same functionality, lower price. This does not always apply. For example, we were a full open source shop until we needed MPLS, and we had to move to a Cisco-based solution. We are mostly a Cisco shop nowadays. Why? Because we needed MPLS, and that's something missing in any BSD stack out there. More redundancy. Well, yeah, there's work being done, but not yet. It's not yet. There's more redundancy and easier management, and there are no licensing upgrade fees. So here's a very brief comparison. For example, we can bring out an HP DL120G5 with 4 gigs of RAM and 250 gigs disk for around 600 euros. We can run OpenBSD and OpenBGPD on that. And the same platform, it's a Cisco 7200 with an MPE G1 with 512 megs of RAM, which costs orders of magnitude more. But you can handle as many as 8 full routing tables with this OpenBGPD config. The 7206 can only handle a maximum of 2 with 512 megs of RAM. If you buy an additional gig, if you get to 1 gig of memory, you can have as many as 3. But the full table loading times are way different. And while you're loading the full routing table, your router will be peaked over, your CPU will peak over, and you'll get packet loss and customers complaining, and all the things associated to it. So this is the second comparison, because we are trying to get more more full routing tables in the game. So here it is. We want to upgrade to a Cisco 6500 with a sub 720 3B XL, which has 1 gig of TCAM dedicated to storing your full routing table, and it will cost around 30,000 euros, depending on how good your relationship with your Cisco representative, with your Cisco sales representative are, and your module configuration. Depending on how many ports you want to have in your configuration, it will probably cost more. But why? The 6500 can give you a higher port density. I wouldn't think of putting 48 fast Ethernet ports on a normal machine, but you can buy more machines and you can buy switches to overcome this limitation. They will probably not be layer 3 switches as the 6500 are, but it's okay. And it also costs orders of magnitude more than a BSD-based solution. It also has MPLS support, which is handy for carriers and not present on the BSDs. And so in the end, we've seen customers change their mind when they look at these numbers. This does not happen 100% of the time, since it's a matter of both technical and layer 8 requirements. Layer 8 is commercial. We obviously tend to push towards the open source solutions. We actually, if you want the numbers, we've had, if you look at the AES numbers behind ours, we have probably 90% of our customers moved their decision from a Cisco-based solution to a BSD-based solution after looking at these numbers, because they didn't need anything that was in the Cisco devices, which they really needed, and they could go cheaper with our ideas and our solutions. They could invest much more money in the replication, in the fault tolerance, instead of putting just money in buying one piece of equipment. They could buy 3 or 4 different servers and run their infrastructure from those, instead of just going with one piece of hardware. Simple case study. I think the idea of behind this simple case study is that we're telling you how we are using these pieces of software at an internet exchange to have better routing. So in these environments where uptime is important and redundancy is important, and you got to keep working 24 hours a day, 7 days a week, we can use this kind of software so you can use it as well in your environments. So MINAP is an example I'm carrying out because I'm responsible for running one of the route servers there. It was born in 2008, and its goal was to overcome the limitations carried on by the MIX, which is the Milan Internet Exchange, and it's one of the only exchanges in Europe which is facility-based. In May 2008, it suffered a couple power failures, which carried out which caused the Italian internet to be flaky in those days. Why this? Because the Italian infrastructure is not really damage resilient. All the international carriers get into the same point in Italy, and they get to the building where the MIX is located. They get there, and then they distribute all over Italy. So a power problem at MIX caused the internet to be flaky because most of the carriers had suffered downtime in Italy. So we decided to create MINAP, which is a distributed internet exchange in the same campus where the MIX is located. The goal was for MINAP to remain free. So a fast Ethernet port is always assigned to members, unless they can apply for something bigger. if they're exchanging more than 100 megabits of traffic, more than 60 megabits of traffic, then they can apply for a gigabit port. And links between POPs are either dark fiber or layer 2 transport, depending on availability. The campus is a mix of 10, 12 different buildings. So between buildings we have either dark fiber or layer 2 transport, depending on the kind of building. Some of them are just offices and just have one small POP. So we didn't spend money to bring dark fiber there and to lit the fiber. So we just bought some layer 2 transport from, got offered layer 2 transport from one of the carriers already there. We are now 20 peers and counting. We have 5 POPs. I told you many of the buildings are just offices. We host one of those POPs. We have no really big players at the moment. The big players tend to stay away from free access internet exchanges, but the idea was to be the first Italian internet exchange to have a route server. Why? Because Google just goes to internet exchanges which run a route server, and Google is not present at any Italian internet exchange at the moment. So MIX, Northern Mediterranean Internet Exchange, TIX, and Topics don't have one. At least Topics is building one right now, but we are ahead of them. So we looked at what other IXes were doing and how they were doing it. Silly things came out. So we look at the LINX way. 4 route servers, 2 on each peering LAN, all Linux and Quagga based. I counted 13 route server outages in 8 months. Some were about only one of them, many about the ones in the same LAN, and an outage occurred over all 4 of them. Since we are peering at LINX, we usually got this mail. You see, we are in the process of recovering this route server back into operation. Sessions will be established in the usual graceful manner, and we hope this to be completed within an hour or so. Why this? Because the problem was related to the architecture of Quagga, which didn't allow the peers to come back all together at the same time when they resurrected the route server. So people at LINX would have to drive to the colo and manually raise up all the sessions, all the 250 sessions on each route server, manually, one by one. And wait for prefixes to be loaded, and then it could pass to the next one. So it took probably took around a couple hours every time one of the route servers had crashed for it to become available again. And so we looked at what other IXes were doing. AMSX was based on Quagga as well. They moved to OpenBGPD in late 2009 and are now rock solid. LowNap uses Bird, and has been providing example configs for others to follow, because they were the first internet exchange in the world to use it. The ECIX is moving towards Bird as well, and LINX is in the process. LINX thought that the good move was to separate Quagga processes into many smaller ones, but they're now moving to Bird as well. So, RSes at MINAP, we decided to make a somehow distributed configuration. FreeBSD and OpenBGPD-based route server and a Linux-based with Bird route server, which I'm not managing, using LowNap config as a base. They're not really advertised as one of our features at the moment, because we're still in a beta testing phase. But we need some more testing, and they're working very well. However, we don't have as many peers as others do, so we can't really stress test them. We still haven't had any outage so far. The difference is that we have around 20 peers, while any route server you can find at LINX has at least 250 peers. So that's 10 times the number of peers we have, at least. RSes at MINAP. This has somehow and anyhow raised interest in bigger players to join our internet exchange. We are having right now requests to join us from We got requests from some Northern European providers which want to come to peer with us because they, like Google, they do only peer at internet exchanges with route server, and traffic has been increasing ever since we created them. Even though we're not advertising them, people know that we have built them, and so they're coming. And we're still small though, but stable. So this is quite the end of my brief presentation. So if you have any questions, I'm available.
Thank you very much for your interesting topic. So I have one question. So you didn't bring up the how can I say XORP, maybe which is one of the
no, not
so
no.
It's finished.
Sorry?
Is it finished?
Yes. Well, you don't hear anybody using it anymore.
Oh, really?
Well, yes. Well, actually, no, it exists. I've tried it once, but no, it's if you listen, if you go on networking mailing lists and ask about it, they'll tell you to just go away. So just not to use it and go with something else, something better.
And one more question. So you said so many customers move to be use the how can I say OpenBSD-based
Yes. Yes.
Cisco. So are they satisfied with the performance, especially for the
Yes. We don't treat carriers as customers. They're just normal end users, which are allocated probably an autonomous system and a /24 network, but they're really happy with their configuration. Actually, the OpenBSD folks will probably know about Fabio, which is one of our customers, NS3. He's one of our customers, and he's using OpenBGPD. He gets fine with it. So yes.
And in addition, I have one question. Sorry. So
yes.
You introduced kindly root server.
Mm-hmm.
So I think root server is kind of a single point of failure. So nowadays.
That's why we have two.
So I'm not sure the root servers. How can I say? Why do we need a root server? I'm not good at the root server architecture. So what is a good point of the root server?
The point is, if you think of going to peer at an internet exchange, you will probably find yourself into managing a large set of different neighbors,
Yes.
which means, for example, I don't know, the example at LINX is that with 260 peers, 60 other companies peering at the same internet exchange, you might get to go out and configure 260 different neighbors and sessions. And you'll probably have to monitor those 260 sessions because you don't want to wake up one day and discover that 50% of them had died in the meantime, and you're not using what you're paying for. So route servers are a means of getting into an internet exchange and then starting to peer with all the other people at the internet exchange by just setting up one session. They create a single point of failure, but that's why we have to, even though we are small. Actually, LINX has 4, as I said earlier, different based on 2 different peering LANs. So they have 2 on each peering LAN, while others still have probably only 1 or 2. But yes, at the same time, normally at an internet exchange, you have peering with your route server and direct peerings with some of the others. Because you may want to arrange direct peering agreements with some of the other companies at the same location, mainly for managing purposes, or you don't want some routes to be passed to the route server, or you might want to probably have another routing distribution inside your private peering might want to do strange things at a peering point.
Thank you.
You're welcome. Any other questions? So, yes.
Did you do any stress testing?
Yes. Well, actually, we only tried to. Well, they have the two route servers we have are all have an Ethernet connection, so they don't pass packets really. They just we could load. Well, the best stress tests are the ones where you load your full routing table and you can load eight of them on the hardware we are using for our route servers. So we don't care about we have about 350 routes collected at MINAP, so we don't care at the moment about how we are handling them. Actually, on my configuration of route server, we don't even do any prefix filtering towards the users. Well, we don't filter anything coming from the users. It's actually there. We just set a max prefix limit, which is tied to any of them, but that's it. While I know that on the bird server we are doing filtering. The guy running the bird filter is much more, I'm going to say, suspicious than I am. So he does filtering based on data from the right database. So the database gets updated. Well, he gets updates from the database probably once a day, and then modify filters on the fly related to what's in the database. But I prefer not to do it because most of the bigger players in Italy don't write anything in the right database in the RPSL part of the right database. So you might end up filtering them all out without not knowing and just not accepting their routes in the. Actually, you know that one of the peers we have at MINAP re-announces some routes learned from another private internet exchange that they have into MINAP from bigger players. So we might end up filtering them, and that wouldn't be a good thing to do. So that's why I'm not doing it at the OpenBGPD. Actually, the configuration file from the OpenBGPD route server, I didn't show it because it's plain simple. It's just setting up neighbors and setting max prefixes. So it's really not worth it to show it out here because, well, it's really simple. And well, we might try to do some stress tests to see how much we can grow before we have to, I don't know, either build another server or do load balancing or who knows what. But yeah, at present we don't care about it because we are just exchanging 350 routes over servers which are able to handle probably 8 full routing tables. So we're not really into it. Any other questions? So thank you for coming. I hope you enjoyed the conference.